Welcome to the second module of the NI Multisim Basics course. By the end of this module, you should be familiar with multisim simulation settings, circuit wizards, as well as how to use virtual instruments and measurement probes. Multisim simulation is unique because you don't need to know any SPICE code to deal with it. At the same time, it provides access to the low-level code for SPICE experts. The netlist, which is a summary of all nodes and components of a design in a text format, is hidden from main schematic view. In case you're an expert in SPICE coding, it can be found under the SPICE netlist viewer. You can even place an arbitrary SPICE block for advanced SPICE syntax, or use the xSpice command line. Most components in Multisim have a model associated with them. Only green components in your schematic do not possess a SPICE model. They are merely placeholders. These components sometimes have more than one SPICE model. This is because they need to adapt the model to a specific simulation. For example, a less complex model might be ideal to simulate a transformer which handles high voltages, and high-precision simulation results are not needed for verification, whereas it is not the best choice for a highly restricted simulation environment where you're looking for exact results. Let's start by taking a look at some important aspects of simulation in Multisim. The simulation functions can be found on top of the workspace in the toolbar sections. It is composed of the start, stop, and pause the simulation functions. Animated parts are components that change during simulation triggered by an event, such as a light bulb lighting when there is a current, or by the user, such as flipping a switch on or off. These are rendered in Multisim with animated sections depending on the state of the component. Virtual instruments can be used for analyzing and troubleshooting circuits just like in real life. Finally, analysis and graphs are there to provide a visual way of presenting information of your circuit in a visual and an intuitive manner. Let's start with the virtual instruments in Multisim. Selecting them is as simple as finding the right instrument in the panel to the right of the workspace and placing them on the workspace to be wired, exactly like a regular component. Every instrument has a front panel that will allow you to adjust and control it to your needs. For example, you'll find the X and Y axis scale controls at the bottom of an oscilloscope to better control the given graph, as well as trigger functions including internal or external, even automatic and custom edge trigger modes. Here we have the same example from last module, where we have a filter connected to a clock signal source. We're going to delete that source simply by selecting it and hitting delete in the keyboard, and then we're going to replace it with the function generator virtual instrument. You can select it from the instrument panel on the right. Notice the outline of the component, and just like a component, place it where the source used to be. Wire the negative pin to the input wire for the filter, and wire the center pin to a ground source. You can place a ground source from the component selection window or simply wire it to an already available one. Now we can configure our source by accessing the control panel. Double-click the instrument to open it and change the frequency to 40 kHz, the amplitude to 1 with 0 offset, and select the sine waveform. We can leave the front panel open and continue working on the rest of our circuit. We're now going to add an oscilloscope and a Bode plotter to verify and analyze the results from the simulation of our circuit. Select first the two-channel oscilloscope in the same way you did with the function generator from the instrument toolbar. Place it and wire both the input and output signals from the filter to compare them. Wire the negative terminals to a ground source and change the wire color of either the input or output net to a different color. These colors will be reproduced in the front panel, giving each signal a different color. Now repeat the above process for the Bode plotter, wiring the terminals to the input and output wires appropriately. Open the front panel and change the values to a horizontal scale ranging from 1 kHz to 1 MHz and a vertical one from -50 decibels to 10. Now, let's simulate the circuit and see the output from both our virtual instruments. Click on the Start Simulation button. You can change the background in the Bodhi plotter if you click on the Reverse button. Close the Bodhi plotter and open the front panel for the oscilloscope and make any necessary changes to view the graph properly. You can change these for the bottom of the panel. You can also watch what happens as you change the value of the potentiometer in your circuit. As an interactive simulation, changing the frequency given by the function generator during simulation will also update the oscilloscope. A measurement probe is a simple and effective alternative to virtual instruments if you don't need circuit values and information with a graphical representation. One of the most important aspects is that they can be placed and used before and even during a simulation and give constantly updated values. The circuit wizards consist of already made common circuits like timers, op-amps, and filters. Select the 555 timer wizard in the circuit wizards option under the tools drop-down menu. Make an astable operation timer with 5 volts Vs, 40 kHz frequency, and 6.8 nanofarads, then build a circuit. Start simulating the circuit, and while our simulation is running, we can select the measurement probe from the instrument toolbar and place it on any net in our circuit. Place one in the output wire from our filter and double-click on the yellow box that appeared. This yellow box shows all the parameters being displayed by the probe, and we can alter these by altering the properties in the Parameters tab. Click to turn off all parameters except for the frequency and the peak-to-peak voltage. You'll notice that now these parameters are the only parameters displayed when our simulation is running. You'll notice that the frequency in our simulation is slightly off. If we go to Interactive Simulation Settings, under the Simulate drop-down menu, we can in there select to change our maximum time step to 1e to the -6. This increases the precision of the time step, therefore making our calculations, thus our frequency, more precise. You can save the simulation settings you used under the option in the Simulate drop-down menu. Name it Smaller Timer Step and save it. You can even insert a description if you like. In summary, we've covered different ways of performing simulation and outputting results in Multisim. You should be able to exploit these features in your Multisim design. In the next module, we'll talk about many of the analysis offered in Multisim, how to enter expressions, and how to effectively use the grapher. But before that, let's go through a quick quiz. Welcome to the third module of the NI Multisim Basics course. By the end of this module,